Okay, folks, let's get started on this next one here. It says, remember that you cannot divide by 0. We know that. That's against math law, and you go to math jail. Okay? You must restrict the variables in a denominator by excluding any values that make the denominator equal to 0. Okay? In example 1, a cannot equal negative b. Now, I'll go back to that for just a second, just so we can look at that. Okay? Now, when we get the denominator, right? Guys, I'll put this in your notes later. We always figure out what the restrictions are before we cancel, because we don't want to lose any of the restrictions. A plus b cannot equal 0, which means if I subtract b from both sides, a cannot equal negative b, because if it does, then I'm going to get 0 in the denominator, and that's against math law. Can't do it. All right? Now, let's look at this one again. It's telling us, make sure that you show the restrictions, and you always figure out what the restrictions are before you cancel. Okay? So let's look at example number 2 here. We've got a couple of things. On top, we've got x squared minus 9. On the bottom, I've got 2x plus 1 times 3 plus x. Okay, well, the first thing that I notice, I need to factor the numerator, and it's a difference of 2 perfect squares. Okay, so that's going to give me x plus 3 times x minus 3. Beautiful. Okay, on the bottom, 2x plus 1, can't factor that. There's nothing that goes into both of the terms. It's not the difference of 2 squares. It's not a quadratic. Okay, it's done. 2x plus 1. Over here, this says 3 plus x. Guys, I'm always going to write that in standard form. Put the variable in front of the constant, all right, x plus 3. Now, what I see is, boom, I can cancel those 2 common factors. Done. But I'm not going to do that yet. Before I cancel, I have to say what x cannot equal. Okay? So, if this whole thing equals 0, then the denominator equals 0. Because remember, from the 0 product property, okay, if I'm multiplying 2 things and they equal 0, if one of them has to be 0. Okay? And if this thing equals 0, then the whole thing equals 0. So 2x plus 1 cannot equal 0. But that same is true as for x plus 3. So that means that x plus 3 cannot equal 0. All right, well, let's solve this, because we don't want to say what that binomial can't equal. We want to say what the variable cannot equal. So I need to subtract 1 from both sides. 2x cannot equal negative 1. Divide by 2. And x cannot equal negative 1 over 2, because that would make this 0. Bad. Okay? For the other one, subtract 3 from both sides. And I'm going to get x cannot equal negative 3. So here are my restrictions. X cannot equal negative 1/2, and it can't equal negative 3. Okay? Now I'm ready to cancel. X plus 3 goes. X plus 3 goes. And I'm left with x minus 3 quantity over quantity 2x plus 1. Okay? This is my answer. It's my restrictions and my reduced fraction. Okay? Now, the only thing that I put down here is what we had just been talking about. To see which values of the variable to exclude, look at the denominator of the original fraction, which is what we did. Okay? Neither 2x plus 1 nor 3 plus x can equal 0. We know that. So, what values for x make it 0? Well, we found negative 1/2 and negative 3. Okay? And then the next thing I put down here myself, always determine the restrictions before you cancel. Because think about this. If we had canceled x plus 3 and then figured out the restrictions, we would not have seen that x cannot equal negative 3. Okay? So we have to determine what those restrictions are before we get rid of that, that factor. All right. Good job, guys. Let's look at the next one.